So noticing that pattern is important. And then when we start to look at that table, we can start to see it. So that table has pieces of information in it, and some of them are filled in. Grab this. And we have our pattern. So our pattern number, N, the white, and then the gray or the black tiles, and then the total number of tiles. So the first one they gave us had 12 white tiles and 13 black tiles for a total of 25 tiles. The second pattern had 40 white tiles, and we want to know how many black tiles it had. So we're looking at this guy. How many gray tiles does it have, or black tiles? 41. Oops, wrong pen. It has 41 tiles for a total of 81 tiles. And you can see that with 1, 2, 3, 4, 5, 6, 7, 8, 9 by 1, 2, 3, 4, 6, 7, 8, 9. That's the fast way to find our total. So notice this is 9 by 9. This one was 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. So we can see that it was 25. It's an easy way to check that. So pattern number 3, they didn't give us anything. What's something we know about pattern number 3? This guy. You can give me white tiles, black tiles, or the total. What do we know? Can you find out how many total tiles it is? Listen. Count how many tiles wide it is. You've got it in front of you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. By 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. So we know this is 13 by 13. It's 169 tiles. From that information, can we figure out how many white tiles and black tiles? What do we notice about the pattern there? Look at the values. Yeah, there's lots of things to notice here. What's different between the black and white tiles? Yep, they're going up too. How about what's different between in like black and white themselves? Look at, there's more black. By how many? By 1. There's always one more black. 12, 13, 40, 41. So is there a way I can figure out how many white and black tiles are here? If there's always only a difference of 1? Could we divide it in half and find exactly where they split? What's 169 divided by 2? You guys have calculators that live in your pocket. Use it. 52.5. So how we, not 52. 84.5. So how many white tiles are there going to be? 84. How many black tiles are there going to be? 85. You can take that total and divide it in half to figure out what our values are going to be. So the pattern that we drew, how many total tiles were there? This one was 5 squared. This one was 9 squared. It's like I know someone said something, but remember I'm old and you gotta be louder. It's 13 squared. Count your pattern. Or we can look at our piece up here where we know it was 4, 9, and 4. See how wide is it? 9 plus 4 plus 4. Or 4 plus 9 plus 4. Nine plus 4 is 13. Plus 4 is 17. So this is going to be 17 wide. So we need 17 squared. So how many tiles are in the pattern that you drew? What's 17 times 17? 289 tiles. How many white tiles did you draw? How do we figure out how many white tiles there were? 144. And you drew 145 black tiles. You drew that. This is the one that you drew. We could continue this pattern up. The point is to start noticing these patterns and recognizing these patterns. Can we figure out what's changing between pattern 1, pattern 2, pattern 3, and pattern 4? What's our pattern here? What's it increasing by? This is our side. Anyone see the pattern? Yeah, the sides are increasing by 4. So my first one had 5 blocks on the side. If we added 4 tiles on the side, we got 9 tiles on the side. Then we added 4 more tiles, and we got 13 tiles on the side. Then we had 13, and we added 4 tiles on the side. We got 17 tiles on the side. So we could continue this pattern up and find however many we wanted. Which is actually what we're supposed to try and notice for part 3. Question 3. The total number of blocks was found. So number 2, we noticed that it was 1 different. Number 3, we found, and we put it in our square. The total of number of blocks found is squaring the boxes on the side. So we had our 9 squared and our 13 squared. That's what these blanks are supposed to be. And then we noticed that those sides were adding 4 and adding 4 and adding 4. So to find number 5, we could take this side, this 17, we could add 4. And we would find out that our sides would be 21 squared. So we could find how many pieces we need for pattern number 5. Pattern number 5 would need 441 tiles. So what we're looking at for part C is we're looking at a way to make this have a variable. And what we see is it's increasing by 4 each time. What that means is that's going to be a huge piece we need right there. Since it's increasing by 4 each time, whatever our pattern number is has to multiply by 4. So pattern 1, 4 times 1. Pattern 2, 4 times 2. Pattern 3, 4 times 3. It puts us really, really close. We have to use this 4n. But then we might need to add something. What's different between 4n and actually pattern number 1? Not the squared. So how do I get from 4 times pattern number 1 to 5? What do we need to do with 4 times 1 to make it be 5? 4 times 1 plus what? Plus 1. Does that work for the others? 4 times 2 plus 1, does that make 9? 4 times 3 plus 1, does that make 13? 4 times 4 plus 1, does that give me 17? So what this is giving us is this is giving us the length of the side of our shape. To find the number of blocks, what did we do with our pattern? What did we do with it? Up here. We squared it, right? So the way we could figure out how many tiles I need, if I need to tile a whole plaza, and I knew it was going to be the 20th pattern, I could plug it in. What we're doing here is trying to write these as expressions. These patterns, especially the ones that have squares, we're supposed to look at the sides of them. Okay, a lot of these patterns are going to come back again and again. We're going to look at patterns like this more. We're going to look at patterns like this repeatedly. Throughout the year, we're going to see patterns like this, where we start to notice it. 4 is really a challenge problem. Question number 4 here. It's how could you find how many white blocks and how many black blocks you would need. Being able to write this expression is the big part of today. This expression, and I know it's not easy. I know this is really hard. I don't know why I have a 3 there. That should be a 2. Sorry. Writing this expression is not easy. It's not. This is where it starts to get a little bit harder. This is kind of the meat and potatoes of this chapter, is writing these expressions for patterns, finding the piece in them. We're gonna do another pattern like this tomorrow. It's 2 pages after this. My book has the wrong pages numbers on it because I have last year's book. Okay, so we're gonna practice with these patterns more. We're gonna practice with these patterns more tomorrow. But this is what the most of this chapter is all about, is finding these expressions, especially in patterns. Okay, so there is a homework about patterns, but we're, again, like I said, we're going to do more pattern stuff tomorrow. So you can look at it, but you do not have to do like the whole thing. If you feel like you can do it, great. More power to you. Feel free to turn it in. No problem with that. If you want to wait and look at it tomorrow, totally fine. Our first chapter test is on the 25th, which is next Friday. Okay? I will get you a chapter review probably by the end of this week. But we have more things we're going to do. Okay, so we're going to be working on finding patterns and finding the expressions in patterns for most of the rest of this week. Okay? So we got to find all those little pieces. And you guys have 10 minutes left in the period.